Okay, so today we're going to look at just simply word problems using all those factoring properties we learned about on day 1, 2, and 3, and using those to solve word problems, specifically word problems that deal with consecutive numbers and Pythagorean theorem, and in some cases, perimeter and area. Let's go ahead and get started. So with any word problem, the first thing we want to do is define our variables. So let's read the problem first. The square of a number increased by twice the number is 48. So we're going to let x equal the number, we don't know what it is, and then x squared is the number squared. So the square of a number, which is x squared, increased by twice whatever the number is 48. And as you can see, it's set up as a polynomial already. We just have to get it equal to 0. So if we subtract 48 from each side, we get x squared plus 2x minus 48 equals 0. And this is where the zero product property comes in. So now we need factor pairs of negative 48 that add up to 2. And factor pairs of negative 48 that add up to 2 are negative 6 and 8. Negative 6 times 8 is 48, and negative 6 plus 8 is 2. So there's our first binomial, x plus 8, and our second one is x minus 6. And we're going to use the zero product property, so we're going to set that equal to 0. So if we solve for x on this one, x equals negative 8. If we solve for x on this one, x equals a positive 6. So the two possible numbers are and we can use either of those and we can check them. The two numbers are negative 8 and 6, because the square of those numbers increased by twice the number is going to be 48, regardless of which one that we use. Okay, if it involves a geometry problem like question number 2, we want to draw a picture. So the shorter side of a rectangle, we're going to draw a rectangle, excuse me, is 3 less than the longer side. So let's call that the length, and this will be the length minus 3. If you want to refer to them as x and y, that's fine too. The area is 54 inches, and we know to find the area of a rectangle, it's length times width. So in this case, L is the length, and L minus 3 is the width. So it's L, the length, times L minus 3, and we know that perimeter is 54. So what we end up getting is 54 equals L squared minus 3L. Using the zero product property, we get L squared minus 3L minus 54 equals 0. So now we're going back to what we did up there in question number 1. What are the factor pairs of negative 54 that add up to negative 3? So factor pairs of negative 54 that add up to negative 3 are negative 9 and 6. Negative 9 times 6 is negative 54, and negative 9 plus 6 is negative 3. So our factor pairs would be L minus 9 and L plus 6. Using our zero product property, if we do L minus 9 equals 0, then the length equals 9, and that works. If we do L plus 6 equals 0, that means the length equals negative 6, and that's not going to work because we can't have negative numbers. So it's asking us to find the length and the width. So if the length is 9 units, then the width has to be 6 units, because that's 9 minus 3. So the dimensions of our rectangle are 9 units and 6 units. So let's say welcome back to our consecutive integer problems. What is the smallest of 3 positive integers if the product of the smaller 2 integers is 10 less than the largest integer? So we have 3 integers. Our first integer is x, and this is consecutive, so it's x plus 1, and then our third integer is x plus 2. So we're looking for the smallest, so we're looking for x. What is the smallest of 3 consecutive positive integers if the product of the smaller 2, and these are the smaller 2, which is x times x plus 1, is 10 less than 10 times the largest. So it's 10 less than 10 times the largest. So the largest is x plus 2, and it's 10 less than that. So let's distribute. We get x squared plus x equals 10x plus 20 minus 10. That's going to give us x squared plus x equals 10x plus 10. Bring the 10x over, so minus 10x minus 10x. That's going to give us x squared minus 9x equals 10. Apply the zero product property, subtract 10, and we're going to rewrite that as, I'll move it over here so we have some more room. We'll rewrite that as x squared minus 9x minus 10 equals 0. So we're looking for factor pairs of negative 10 that add up to a negative 9. And those factor pairs would be x minus 10 and x plus 1 equals 0. So if we use the zero product property and x minus 10 equals 0, then x equals 10. If we do the same for x plus 1 equals 0, then x equals negative 1. So it says positive integers, so we are not going to use this one. So the smallest of the positive integers is 10, the next number will be 11, and the next number would be 12. Okay, let's see if you can try example number 4 on your own. The larger leg of a right triangle is 2 centimeters longer than the smaller leg. So right triangle, so that's what we're going to draw. So the larger leg we're going to call x of a right triangle is 2 centimeters longer. So it'll be x plus 2 than the smaller leg. The hypotenuse is 4 centimeters longer than the smaller leg. So we have x, x plus 2, and 4x. So we need to find out how many centimeters long is the smaller leg. So the Pythagorean theorem says that a squared plus b squared equals c squared. So if we plug in x plus 2 for a, x for b, and 4 plus x for c, we need to multiply those polynomials and then combine like terms. X plus 2 squared is going to give us x squared plus 4x plus 4 plus this x squared, and then x plus 4 or 4 plus x squared is going to give us x squared plus 8x plus 16. If I combine like terms over here, I get 2x squared plus 4x plus 4 equals x squared plus 8x plus 16. I can subtract x squared, and I can also subtract 8x, And I can also subtract 16 to use that zero product property. And when I do that, I end up getting x squared minus 4x minus 12 equals 0. So we're going to use that zero product property. What are the factor pairs of negative 12 that add up to negative 4? And those factor pairs of negative 12 that add up to negative 4 are x plus 2 and x minus 6, and that's equal to 0. So if x plus 2 equals 0, then x is equal to negative 2. Can't use that because it's negative. If x plus 6 or minus 6 equals 0, then x equals 6. So we're looking for the smaller leg, so the smaller leg is 6 centimeters. Okay, now it's your turn to answer multiple choice question 1. Write the equation to model the situation. When 10 is subtracting from the square of a number, the result is 3 times the number. So keep in mind the parts. When 10 is subtracted from the square of a number, the result is 3 times the number. And keep in mind that is always equal to. And then from number 1, what is the positive solution? There'll be 2 solutions, a negative and a positive, and we just want the positive. Be sure to enter your answers in the Google form.